So welcome everyone to today's webinar, Charged for Success, Insights Driving the Next Era of Utility EV Programs. To kick us off today, we have Žiga Ivanic, Senior Program Director for our CLEAResult Energetics Sustainable Transportation Team. And so he's going to introduce our agenda for today and our other panel of experts.
Thank you, Nick, and welcome everyone. Thanks for joining us for the CLEAResult Transportation Electrification webinar. Today we'll share insights from various project involvements of our staff that are helping inform the next generation of state and utility electric vehicle charging programs nationwide. My colleagues Kevin, Brian, and Ewan, each of whom has managed numerous transportation electrification projects for utilities, state energy agencies, and commercial clients over the past 15 years or more, will share a few golden nuggets on medium-duty, heavy-duty fleet electrification, electric school bus deployments, including vehicle-to-grid pilots, and EV charging data collection analytics. These insights come from the largest third-party evaluation of California investor-owned utility transportation electrification programs, which we've been evaluating over the past 5 years in partnerships with Cadmus. And that represents more than 700 million in EV charging infrastructure investments, where our teams conducted over 300 site visits with fleets. Additionally, you'll hear from Brian on a 4-year Department of Energy sponsored EV Watts project on EV charging data analytics, and several V2G school bus pilots that Ewan's going to share some insights. So Kevin, please start us off with the medium and heavy duty fleet electrification insights.
Thank you for that introduction, Žiga. Next slide, please. So as Žiga mentioned, we're part of a team that's doing the largest utility evaluation for transportation electrification programs in the nation. To the left is pictured our 2024 evaluation report, which is where most of this data comes from. We're currently working on our 2025 evaluation report, which will come out later this year. But at the end of last year, there was over 200 utility, medium, and heavy-duty fleet sites in the evaluation, and it's well over 300 now. When we look at kind of where the market's going, medium and heavy-duty vehicles are becoming kind of the largest participants in the program, both based on the number of vehicles, which is shown in the chart below, but also from energy use. The heavy-duty vehicles are using a lot of energy now, but school buses have historically been one of the largest sectors in these programs and have the largest number of vehicles as well. But despite the early lead in the school bus sector, we are seeing the school bus sector is continuing steady upward growth or even accelerating growth, with lots more deployments continuing to happen. Next slide, please. So one of the things we look at in these programs is their grid impacts, and as utility programs, the gold standard is to see if you can deploy vehicles and have kind of good load growth that puts downward pressure on rates. But we do see what we say is significant unnecessary consumption between 4 to 9 p.m., which is the highest cost time period for all utilities here in California. And surprisingly, only about 21% of the sites, which was 45 out of 219, exhibit use of active load management, which, to turn that around, that means that more than 3/4 of sites are not actively trying to avoid the highest cost time periods or otherwise shape their demand in a way to reduce costs. We do see in all utilities, we do see a steep increase in weekday demand after 9 p.m. So there are fleets that are managing their load, and that includes some of the bigger fleets. So the percentage of load under management is slightly higher than the percentage of fleets. And minimizing the overall demand has been less of a focus for these fleets than simply just avoiding that that highest cost time period. Next slide, please. So that showed curves by utility, and they were relatively, consistent between the 3 large utilities we're evaluating. This slide shows the load curves by market segment, which is kind of interesting and informative. But across all market segments, again, you do see substantial usage in that highest cost time period. We also like to divide everything out by weekdays to weekend because the trends can be different depending on fleet operations. So that the heavy duty vehicles has a relatively steady usage through 4 to 9, and then you see that large peak after 9 p.m. Medium duty vehicles, which includes things like delivery vehicles as well as pickup trucks and work vans, those you actually see peaking in the early afternoon. Many of those vehicles are on earlier route shifts and come back in the afternoon. It starts to decline after 4, both as a result of load management, but also some natural, the vehicles are just already getting fully charged by 4. And then we do see some growth again after 9 p.m., both managed and unmanaged. School buses are one of the most interesting cases where traditionally we see a double hump for the electric school buses, is they can come back in and plug after their morning run, and often they need to have enough charge to make all their afternoon runs. But many school buses do come back after 4 p.m. and plug right in, and if they don't have load management instituted, they're going to start charging, and they're going to peak again right at 6 p.m. or so, which is right in the center of that highest cost, most grid constrained time period. But then we do see, with the number of school bus fleets that are starting to manage their load, we see that additional peak after 9 p.m. And then on the transit buses, we see it slowly increasing through that time period with a peak after 9, which reflects both load management as well as many transit buses are just getting back from the ends of their routes about that time. But for all these fleet types, we definitely see more opportunity to manage their charging. For school bus fleets, one opportunity is actually to move to the weekend because they have very little charging usage on Saturday or Sunday, and other fleet types have some usage on Saturday, but less so on Sunday. So if we look at the midday as kind of one of the lowest emissions time periods now, that's a great opportunity for all the fleets to move some of that charging to both a lower cost and lower emission time period. And if we move to the next slide, one of the things we've done in this evaluation is an optimization analysis. So using kind of network service provider data that looks at plug time versus charge time, we can see when the vehicles are plugging in and when they're actually charging. And so we've identified a lot of fleets with a lot of flexibility that could, if the fleets were optimizing for moving their charging to lowest cost time periods, we see savings of about 24 to 31%. And there's also, we've also done some optimization for emissions, which generally are lower for utility emissions in the day when the sun is shining here in California. SCE and PG&E both offer their lowest rates in the midday every day, but a larger midday cost reduction for PG&E, SDG&E could create a stronger price signal that encourages fleets to charge both at a time that's lower cost, but also a time that's lower emissions, and could also serve to reduce that 9 p.m. spike, which is a lower cost, but not necessarily the lowest emissions. And SDG&E 2 months of the year has the lowest cost at 10 to noon but that makes it harder for fleets to optimize their emissions the rest of the year. So some of what we're doing in this year's evaluation report is really digging into why fleets haven't taken this opportunity to optimize their costs more, since there is some pretty clear utility price signals, and we're identifying a variety of hardware, software, as well as just some behavioral issues that need to be addressed to help fleets better manage their load, so that these new loads are more efficiently integrated with the grid. And with that, I'll hand it off to Ewan to talk more about the opportunities that school buses specifically offer to the grid.
Yeah, I appreciate that. Thank you, Kevin. So for those of you that know me, I'm incredibly passionate about school buses and the opportunities that they hold. So next slide, if you could. So over the past few years, we've seen unprecedented federal support for electric school buses. We're up to over 8,000 electric school buses funded nationwide. They're still rolling out. We have seen a reduction in federal funding, but it's not ended. And the reality is that we believe that this is the time to move clearly out of the pilot phase and into real large-scale development or large-scale deployment of utility programs to facilitate these electric school buses. So in general, these have a great opportunity to move what could be a grid strain into a tool to improve resilience and efficiency. I think you saw that on Kevin's slides a few minutes ago. I'll highlight it again in a minute. But all of this really depends on thoughtful planning, realistic assumptions, and experienced partners who can understand both the transportation side of things as well as the electric grid. So next slide. So what you see here, this is very characteristic of all the fleets that we work with. You can see these characteristic 2 humps, a morning route and an afternoon route. So this theme should carry for about 180 days per year for all school districts. Then the other 185 days that are there are available for kind of unbridled use of these buses for charging. These buses tend to have much higher energy capacity than light duty fleets. They generally run between 100 and 400 kilowatt hours per battery pack. So what we've seen here is that there's just a phenomenal opportunity to use them for VGI opportunities. They do, the majority of electric school buses today are deploying lithium iron phosphate batteries, which are more favorable for V2G use than the NMC batteries that are used in a lot of the light duty applications. So maybe if we can move to the next slide. You'll see that in a typical V2G application or VGI application, you see this diagram on the right. These are all the parties that are involved in a VGI deployment. And you can see that there are, you can imagine that there are, the coordination of all of those parties is pretty critical. For electric utilities that we work with, the key point here is to design your system around the problem that you're decide what your problem is that you're trying to address with a VGI application. You know, are you trying to increase your are you trying to decrease congestion on specific distribution circuits? Are you going for transmission level opportunities? Do you have specific location-based congestion issues? And then you should build your program around that and how VGI can address those core problems. So often there's just kind of an urge to just kind of learn what you can about VGI. I would caution you to not start with just deploying a program to learn stuff about VGI. We've been involved in a lot of VGI programs that have done that, and they just kind of fizzle out. The better way to go about it is to pick your targets and have those targets underpinned with a careful design and evaluation, and really pay attention to your data and insights, which I think Brian will talk about in a few minutes. So next slide. This is what we've called the hierarchy of needs around VGI deployment. Essentially, don't try to move too high up that pyramid before you've mastered the lower level things. You saw it on Kevin's slides earlier, where until those districts have mastered smart charging, there's not really a point in moving towards V2G. One of the V2G opportunities that we were evaluating or working with, we found that they were getting about $1,000 per year worth of peak load curtailment funds, but on the flip side of that, they were spending several $1,000s a year in increased demand because they were charging at the wrong times of day. So you can imagine, if you're not mastering the smart charging side of things, there's not really a point in moving towards the V2G side of things. So anyway, in general, it makes sense to, once you've mastered demand response, then it makes sense to move towards the full bridge technology that's needed for V2G. A lot of the V2G electric vehicle charging stations have the ability to swap out the internal components and put in full bridge technology and move to a V2G scenario. That's where you would probably start with something like peak load curtailment. And then once you move past peak load curtailment, you could move to emergency load V2G, where you're supplying other buildings, other facilities, and then finally really exporting larger amounts of power at the same time as maybe starting to master some of the components of VAR support. And then once you've mastered that, then I think it makes sense to move into this smaller peak of providing ancillary services with voltage regulation or frequency regulation. Anyway, the point behind all this is defining your grid service use case early, and then documenting those lessons using data collection and real-world data to inform your future program and rate design. And that's one thing we've worked with a lot of utilities to help move that direction. So I'm going to hand it over now to Brian, who will talk to you a little bit more about EV charging data. So thanks, Brian.
Thank you, Ewan. With both the projects and what Kevin and Ewan have described and talked about, some of that is lessons learned from going on site, talking with the site owners, operators, and understanding what's going on at the site itself. But also a lot of it comes from data that we can process, that we can understand what the trends are, and come up with actual key performance indicators for each of these projects. It's important for advanced demonstrations like Ewan was talking about, vehicle-to-grid integration systems, but this is also necessary for deployment programs, just getting light-duty infrastructure out in the market to help all electric vehicles. When we do this, it's really important to make that investment not just in the infrastructure itself that's going on the ground, but also putting a little bit toward monitoring and measuring what's actually happening once these are out in the market. Key information is usually energy, how much was actually dispensed and when that was, just so we can calculate the benefits based on that displacement of gasoline from combustion engines because of these electric vehicles. Furthermore, as we want to look at program design and really understand what's working well, we want to look at where that charging took place, what type of charging it was, maybe what type of vehicle. Another key aspect here is looking at both plug-in time versus active charging time for that vehicle when it's at that station. Diving a little deeper, we may want to look at some behavioral-based information. Why are they charging at these locations? What influenced that? Sometimes this requires surveys, but also you can use vehicle telematics to give you some insights on these items. But it is a little harder to capture. One of the key sources of data we found that cover a number of these KPIs and data points is charging station data from network service providers. There are established protocols from charging stations with the signals and the data that needs to come out of them, which is a good thing. So we have it in a standard format, and we're getting a lot of the same signals from different providers. Unfortunately, it also kind of creates a little Wild West atmosphere, and we've had a number of NSPs join the market, leave the market, and of varying degrees of what the quality that they can provide. On the side there, you can see a number of them that we're working with currently today through our various projects. And this isn't even all that are out in the market. So we've seen a lot from different network service providers, but working with them, we've been able to really establish collaboration and get decent data to derive these insights that you've seen already from Kevin and Ewan. Next slide. As we look at the good, the bad, and the ugly of EV data collection, it is numbers which gives us the opportunity to provide analysis from these. We can calculate results, we can calculate impacts based on the data that we're seeing. We can generate and create algorithms and pipelines to ingest this data, aggregate it together, and show it on graphs and other dashboards. When we have the opportunity to get multiple sources and they agree with each other, that's a great benefit to validate the data that we're seeing. Unfortunately, there's a lot of challenges we run up with as well. There's a lot of quantity of data that comes in, particularly when we're talking about interval data every 15 minutes, getting some data points. For every single charging station, thousands of charging stations, it can start to add up pretty quickly. The quality of data can vary, as I mentioned, from network service providers and others. You get a variety of data that's coming in with errors, without errors, and we need to sort that out. When we have multiple sources and they conflict, that's another challenge that we deal with. And we have to decide which is the truth among those two. We also have various formats coming in, whether it's different network service providers or even within the service provider itself that might have changed staff or done something different in their system. All of these challenges we've found ways to overcome, and there are approaches through our experience we've found to deal with all of these situations. When we get to the ugly, that's where there's just not much we can do on our side. When there are data gaps, we don't have data at all for us to manage, manipulate, or try to make sense of. Similarly, unrealistic data that's coming in, we know can't be possible based on the vehicle, based on just the levels that we would see from a particular charging station. That's data we can't do anything with, and we have to go back, hopefully get new data, but with what we have, we really can't do anything. There's also human manipulation that introduces errors and issues into data sets. When you have a prescribed data format that's really nice from an aggregator standpoint, yeah, it's easy to integrate them all together. They look the same in theory, and we can combine them together. Unfortunately, using a prescribed format for data means a lot of these providers have to export it themselves. They have to move columns around. They have to possibly even do calculations themselves. There's no way to track all that movement that happens. And inevitably, there's going to be errors that get introduced because of that. What we approach and what we found successful is to start with raw data. We're able to handle that. We can do calculations as necessary. We can track the process of moving that. But try to give us data directly from your system for us to work with, so we know that that is the truth, or the best truth that they know at that time. The next slide gives us a good example of how we can use multiple data sources to give some insights. Charging station data, there will be gaps. There will be times when there isn't charging happening. Is that real or is it not? For us, network service providers usually give us two streams of data. We have the session data, one entry for every single charging event, and we get the totals for that. We also typically get interval data. So they'll give us 15-minute average throughout that charging period. How much is the peak demand during that period? From that, we can determine and usually validate the two against each other. When we have utility AMI data as well to compare to, this is where we really can make sure the data coming from the network service provider is valid. You can see from the examples here, in a couple cases, the first case, we are seeing some from the session data, but there's probably some missing that wasn't captured based on the AMI information. And we certainly didn't have interval data during that time. Some other indications, the middle one was definitely a gap from the network service provider, but we did see data. It was actually energy being transferred at that time. So that means we need to go back. We need to try to track down that information. Next slide. The different data sources I've been talking about, I'll go into a little more detail here. Utility AMI, a lot of pros to it. It is trusted. It's very uniform. Usually it's very reliable for us to get and has it in a trusted format where we can capture all the energy. Note, this is actually all the energy coming through that meter. So we're actually seeing some energy while there is no session happening from just ghost energy loads that may occur, particularly with DCFC chargers. The challenge here, we don't get much EV information. The 1 meter may be attached to several charging stations, so there might be overlapping sessions we're trying to deduce how to divide apart. There may be other things connected to it. There might be a light connected to that same circuit that you don't know about, or it could be a whole building load that just has some chargers that are added to it. So you do have to make some inferences and really process that data carefully to try to deduce what might be happening from the charging station itself. Vehicle telematics are another opportunity of data. Really complex, comes from each vehicle. It's very detailed. You know what's happening with that vehicle, where it's charging, how it acts. This really touches on the user behavior and why somebody might be charging in a particular station, and has an accurate account of the state of charge. So did it arrive at that station and absolutely need a charge because it was down at 10%, 20%? Or did it just arrive there and want to top off? You'll actually know what type of vehicle, whether it's a plug-in hybrid, whether it's a battery electric vehicle. So that's some really good user information you can get from telematics. Unfortunately, they don't have an accurate meter on the vehicle that calculates the energy. You're estimating that a lot from the state of charge. There's a lot of different data fields for electric vehicles coming out of the onboard diagnostics. It can vary a little bit. It's not as standard as some of the other fields in there. And there's a lot of information. You're getting everything from the vehicle, position data, and everything else. So it is a lot of information that you would need to process to trim down and understand the charging aspects. So that leaves us with the source that we most rely on is charging station data from network service providers. As I mentioned, there are protocols, so it is relatively uniform coming from each one. Yes, the quality differs a little bit, but in general, it's fairly similar. We know what we should be able to expect and get from each of them. We are able to understand what the plug-in time is, so when they actually arrived at the station and connected, and when they're actively charging during that period. That provides a lot of insights into how we can maybe move the move the charging from one period to another or flatten it out. And we get energy and demand from this. It is just a single location. We don't always get good information on what type of vehicle was plugged in, but it is solid information that we can use and do our analysis with. It is also possible if they lose a signal because of the satellite or interference, there could be gaps in that data as we just saw previously. Next slide. Here I'm showing some insights from our nationwide EV Watts program where we looked at light duty and fleet chargers all across the US, trying to look at general trends and what's happening. For this, we did collect data from network service providers, and on the left, you can see some analysis based on that. This is an office location, and we can compare plug-in times versus active charging times. Plugging in, we see that bump where people just left their cars all day long when they arrived at work and then left 8 to 9 hours later. But on the bottom, we can see that charging really happened during the first point of that, and then many just stood there idle. So that, again, exposes an opportunity to maybe flatten this curve or move it to times when we want to charge or it's more advantageous to charge. On the right-hand side is telematics data analysis that we've done. Again, we can see different vehicle types, and we've bucketed these different ranges for battery electric and plug-in hybrid vehicles, and can see some differences between them. For charging sessions, what is the state of charge when they arrive, when they leave? Where are they actually charging? Home, work, other places? How far away from home are they when they're getting these charges, and what stations they're using? So these are additional insights, but a little less accurate information on the energy itself. Next slide. So finally, as we wrap up, there's many reasons why we collect charging station data. For many programs, it is to meet regulatory reporting requirements, and it absolutely can do that to get the energy and what benefits might have come from that. And we're also tracking other impacts toward the grid. When is this happening? What are the other benefits that could happen? But we can also use this to inform future planning. As you're looking to roll out new programs, which deployments were more successful than others? Why were they? How can we integrate that into our new programs and make them the most successful? Ultimately, from a data standpoint, our recommendation is to start with the NSP data. This is typically used for any network service. Network station already has it. If they're looking to charge a fee just for monitoring purposes, it's already being included. So there's usually not a huge cost to getting it, and we can handle that data flow. Our team has come up with algorithms and approaches to do so, to give us a pretty complete picture of EV charging. These other two sources, as I mentioned, utility AMI is great to fill in gaps or validate the data we're getting from network service providers, but in itself is a challenge to tell the whole story. And then vehicle telematics, a lot of data to process, some very interesting insights that you can get from it. But again, it has limitations to give us the key information we need. So we suggest adding this on at the end if possible to give those additional insights, but not using it for the core basis of your analysis. And with that, I'll turn it over to Zhiga to wrap us up.
Thank you, Brian. So you heard today from us on the state of fleet electrification with utility and state programs that are continuing despite of the cooling trend at a federal level. So while one size does not fit all, there are medium and heavy duty market sectors that are finding success with electrification. Some still heavily reliant on federal, state, and utility funding, such as school bus and transit buses, but some sectors are starting to emerge, such as yard tractors, medium heavy duty, drayage fleets, medium duty delivery, that are starting to see the ROI potential on the horizon. So we'll move to the Q&A portion of the webinar and see what questions we have in the chat. And to start us off, Brian, since you just presented on EV charging data, we showed over 50 different network service providers we work with on slide 15. Do you have a favorite among those in the 14 years that you've been working with them?
Well, we actually absolutely see a variety from these different network service providers. Obviously, all of them think they're the best and doing well, but what we use is actual data to validate that. How well are they at reporting, turning the stuff in? One of the keys is actually communicating with us. Somebody that's not communicating goes missing. We end up having a lot of gaps from and issues for. Those that communicate well with us, we can work with them. It's a collaboration that really works and ends up with success. So ultimately, there are certainly multiple tiers of quality for our NSPs. And what we do while we're doing collecting data based on how much is reporting, how many errors are in their data, we create a scorecard and we can present that from real world actual results that they're providing us, how well they're doing at complying. And from that, we can use that information to feed back to the program, whether they want to decide to move some off of a qualified list or work with certain ones during future programs. So we can provide that feedback to them based on the real world results that we're seeing.
That's great. Thank you, Brian. And we're seeing a lot of utilities have approved product lists. Usually that's driven by the hardware for the charging stations, but more starting to add kind of the network service providers to that as well, just to kind of help ensure success from interoperability and data and reporting and the managed charging as well. Kevin, in terms of the managed charging, so with utilities we work with, or if you're advising a utility that's about to embark on a implementation of a fleet program, what's your advice? What can utilities do to help increase the uptake of managed charging? Because the whole idea of this energy transition from petroleum to electric fuel really is to fill the valleys while not increasing the peaks, right? To increase the grid demand.
Cool. That's a great question, Giga. And I think the first step is really understanding the data. And so utilities need to kind of review their customer charging data for every fleet to identify the opportunities for managed charging. Through our California utility evaluation, we've developed a variety of dashboards that help do that you can identify fleets, looking at load curves like I've shown, but also flagging fleets with high on-peak percentage or low on-peak percentage, or looking at different trends in energy usage. But with that data, you can then go back and reach out to those individual customers to help coach them. Many utilities are developing technical assistance programs, and that's a great opportunity for the utility or through a contracted entity with the utility like CLEAResult to do that kind of study and develop a plan with that fleet to better manage their charging. We also often see that the fleet managers don't see their electric monthly bills and don't have the bandwidth or technical understanding to implement managed charging. But the charging data we have shows a lot of low-hanging fruit. And definitely, I think that the number one thing is you can't always rely on the network service providers directly to provide good support for managed charging. So the utility has to be involved in helping to push for that managed charging.
Thanks, Kevin. And yes, part of the work we're doing, as mentioned, with Cadmus in California, evaluating the medium heavy duty EV charging infrastructure deployments. There's a 500-page plus report. Kevin, if you want to throw a link in the chat for anyone interested, that we publish every year. And there's over 100 charts that show different grid impacts from different market sectors. Like we showed just a couple in this presentation, but there's a lot more in that report. So a lot of valuable information for anybody that's interested in load curves and billing and demand and consumption impacts. So Ewan, one for you, and we'll see if there's any other questions in the chat. We talked about the pyramid of hierarchy of charging needs. Kind of where do you see state of the art today, and what is the next hurdle that you see V2G needs to overcome? So we've seen maybe up to a dozen of pilots across the US over the last 5 years, but a lot of them tend to fall a bit short of their ambitious goals at the beginning. So the technical side of passing energy back to the grid has been proven, but kind of where are we at and what's the next hurdle to overcome?
Sure. I mean, the bulk of it is sort of emergency load reduction, curtailment, and sort of arbitrage, where you're just sort of taking power at one time of day and moving it to another time of day. We haven't seen a whole lot of sort of widespread optimization of distribution networks or anything like that yet. I think that's the area to start pushing for, is really paying attention to what the needs on, as a utility, what the needs on your distribution and transmission grids are, and utilizing V2G programs or utilizing pilots to optimize those. And so start with that goal in mind and see how you can change the utilization of specific distribution circuits to shape them the way that you want them shaped.
Thanks, Ewan. And kind of one question for any of you to to address for utilities that are fielding kind of fleet charging programs and fleets that are beneficiary of grants from federal, state, other levels. Like where do we see kind of opportunities to help fleets electrify? The timelines are challenging. Sometimes it's education, depending on the fleet. They just don't have the resources to understand the technology. But kind of what's the one thing from each of you or any of you that you feel is the next large opportunity to kind of help move the needle with deployments from someone not having a great experience and choosing not to pursue this because it's too complicated, it's not working, too many stakeholders involved, to we've seen fleets that have had success and want to do more of it. Kind of what do you guys think about that?
I think it does go back to the hierarchy a little bit that Ewan was referencing, and we see it in other programs first. Make sure you walk before you run. A lot of these with bad experiences are just biting off more than they can chew initially. Start with something that's manageable. Make sure it's proven. Make sure it gets acceptance from the fleet, from users. It's working well. Collect that data, validate that it's working well, and then really start to roll it out. I think we saw that with the California programs as well. There was some initial pilots that took place to really validate what were the best markets for these, and now they're moving forward with those. So I think it's really important to phase in a little bit and make sure everything is working right before making a big investment and possibly, trying to encounter too many challenges that leave a bad taste in your mouth.
I'll say on the school bus side of things, we've seen a lot of failures in the sense of being either dabbling or doing too small of a deployment. They're like, we'll just try it. So they buy one bus or two buses, and they don't take the time to dedicate the resources to learn the things that need to be learned, and they end up either getting slammed by demand charges because they're charging at the wrong time. They haven't trained their drivers on how to drive the buses, so they're getting much higher energy consumption per mile. Those types of things, that tends to be what causes a lot of these pilots to fail. Whereas if you do a very conscious but slow, methodical transition, you can really affect a lot and have high performance, I'll say. And partnering with a bunch of people. A lot of people seem to, a lot of districts seem to just try to electrify without consulting a whole lot of people, and I end up talking to them and scratching my head, wondering why they didn't ask the utility for more help, or ask. There's a lot of nonprofit agencies that are available to help.
So they're not in it alone. And Kevin, you and I did a bunch of site visits just this past week. Literally got back from a few you did in the Northern California. Boots on the ground, kind of what are you hearing from the fleet operators? What's that perspective like?
Yeah, so I mean, in a lot of the fleet operators, or even if it's a facility construction manager, who we talk to when we're on site, or often both, they didn't realize how complicated this project was when they were going to start, and they said, "Well, this is my first EV project, and it's probably going to be my last EV project because we've now electrified our fleet." Or put enough infrastructure to electrify the bulk of our fleet. So I definitely echoing the partnership and the using all of your resources, whether that's your utility, local government, or local nonprofit groups that are helping to promote electrification, is utilize those resources out there. And there's definitely a great opportunity to learn from the early pioneers. We put the link to the evaluation report into the link here, and definitely doing some more research before you jump in is great. But it's a new process for most individual fleets, but we also do see some national fleets now that are taking early lessons learned on some of the first sites and putting those into new sites, or we've heard about some national fleets that started in California are now implementing EVs elsewhere and are taking their own lessons that they've learned internally and applying those to future sites.
Thanks, Gavin. Brian, do we have any questions in the chat we want to take?
Certainly. So I see one about network using data from service providers, failed sessions. Sometimes we do get a record of that. We'll get some sessions with zero energy transfer. So we do get some of those recorded, but absolutely, there are some we missed. Some of the things in some projects with enough availability, we can track down and identify how those are performing out in the field, whether it's just feedback from like PlugShare or other places. And certainly if we see a station that has a lot of errors in it and it's not reporting data for a while, we have some initiatives and opportunities to try to track that down and find out why that's happening, so we can kind of investigate a little further to get insights from other places.
Any others, Kevin, that you want to tackle in terms of questions, or you, and feel free to jump in. You're on mute, Kevin.
I was going to say, I was actually going to pitch this one to you and on DC versus level 2 charging for school buses. We do in the field, we see a mixture, and we often see fleets with a combination of both. But Ewan, do you want to talk a little bit about the considerations
Yeah, so
for school bus infrastructure?
We do a lot of, on the school bus side of things, we do a lot of fleet electrification planning. And typically we always recommend a mix of DCFC and level 2, to be honest. Not always. There's a couple of cases where we recommend all DCFC, but it usually has to do with how sophisticated the fleet operator is. If the fleet operator is likely to utilize a managed charging provider, where we feel like that they're capable of avoiding peak utilization, we will recommend a higher mix of DCFC. But in cases where we have seen fleets that implement DCFC in high volumes but do not use a managed charging provider, those those fleets end up really getting hit with demand charges pretty hard. And you know, you saw it in Kevin's chart there, where these school buses, they come back and they plug in, and when they plug in, it's usually around 4 p.m., which is usually around the time when demand charges are the highest. And if you have high kW DC fast charging, you're going to get hit with that many buses times that kW of demand. It's going to be through the roof. So yeah, we often recommend starting with a blend of level 2 and DCFC, and using the DCFC more as a kind of an emergency use case, but leaning on the level 2 for the bulk of your charging. And then as you become more sophisticated, or as you climb that hierarchy of needs, you can take better use of the DCFC.
Thanks, Ewan. And Natalie,
Yeah, I
thanks
see
for your
some-
questions.
Yeah.
Or Brian, go ahead if you want to follow
Yeah, I
up
see
on that.
some questions about, starting a new market, what is kind of the low hanging fruit to apply to things. I know there's certainly, we've seen some evidence where, yes, there are programs set up and give larger incentives in disadvantaged communities to put charging stations. And sometimes that feels good, but it also means some of these stations go out there and hardly get any use because there's just not the population that's there. So I think, we need to be facilitating everywhere where we can to provide those opportunities for people. But, may want to, gauge that with also making sure there's the most impact for some of these programs. So if you're starting off small, starting off with something, I would recommend, starting with supporting fleet programs. A lot of fleets, have control of their vehicles. They understand their routes a little better. They're a little more consistent. If we can convert them, they're using their vehicles usually a lot. We can grab some that are using good duty cycles, maximizing electricity and offsets with those. Nonprofit organizations that are using, vehicles for food bank, for other, transporting people in a community. Those are, I think, great opportunities, gives exposure to it, and it's more of a controlled environment. So that might be a good place to kind of start off, and also kind of check the box of making sure we're trying to help some of these underserved populations.
Yeah, one thing to add there, there's a Choose EV as a tool that CLEAResult has developed internally, and it's used by, I think, over 400 utilities, and it's kind of a starting point, someone that's just starting out with education of customers to try to understand what are the market needs. It's a simple tool. It's like a online EV calculator. That's how it started, that you can plug in some basic information and see is EV right for me type of thing. And that goes from consumers to also commercial fleets. There's kind of different tools even helping with the charging infrastructure. So that's what we've seen a lot of utilities kind of start with, and then they build out their programs after that, whether you got to look at your market you're addressing, what the cost would be. You usually have a regulatory commission you got to propose a program and budget to, so it does take some time. But looking at utilities, in California, we evaluated the first round of projects that was about 22 different pilots to see what makes sense, from incentives to dealers to customers to EV charging infrastructure to public charging, a lot of different things before these scaled up programs came along. So Choose EV is an example of how a lot of utilities start. But like Ewan said, this is a bigger community, a lot of opportunity to learn from each other. Don't go it alone. A lot of resources out there. And as you can tell, we are very passionate about what we do, and we practice that in our daily lives by driving EVs, and happy to field any questions and follow up or engage with anybody that is looking for more insights. Couple more questions we'll try to get to before the top of the hour. Kind of what's next for bidirectional charging? What opportunities? I think, I'll give my 2 cents. You and others jump in, but I think on a residential side, on the private vehicle side, we've seen the Ford Lightning, Chevy Silverado products that come with bidirectional chargers, and it's really for consumers to experiment with this as a novelty in a way. Whether you want to power up a bounce house for your child's birthday party in the park, or when you lose power at home, or if you want to have a generator in your vehicle essentially. And then on the fleet side, we're kind of seeing, obviously, school buses are the main ones, with AES Indiana, CLEAResult helping look at even transit buses and other applications as a pilot. But it's really what does that do to the grid? And you and we're working on an existing project on an East Coast. Yes, utility can send a signal. In a perfect world, the network service provider will respond with the buses that are plugged in, but how much charge is there? How much can you deplete the charge based on the temperature of the battery? There's a lot of constraints that come into play. So the theoretical possibility versus reality, that's kind of the edges of that envelope that are being explored. But you and feel free to add.
Sure. Yeah, I mean, I don't think that it's going to. I mean, if you were to use the news as a way of gauging where we are with V2G, you would think that everybody's doing V2G. There's fairly limited deployments. Those deployments are all quite successful in the sense that they're able to put power on the grid. It's just more sort of what the coordination is with the utilities, what the coordination with the rate structure is, working with the Utilities Commission to really allow for wider spread use of it. In general, it's being done through data aggregators or through service aggregators, much the same way that large-scale solar is being done, or large-scale stationary battery deployments are being done. I think that it's going to go fairly slowly and smoothly. I do think that we'll start seeing it in our light duty vehicles, but mostly on level 2 charging.
Yeah, thanks for that, Ewan, Kevin, Brian. Great insights. Thank you for sharing, Nick. Thanks for organizing the webinar. Thank you for all the questions from attendees, and for everyone that joined us today to attend. The slides will be posted as well as the recording. And yeah, please reach out with any questions or follow up. We'd be happy to engage and help. So thank you, everyone, and enjoy the rest of your day.